Workforce safety must be the top priority of every business. To reduce workplace injuries, employers should develop safety plans, conduct risk assessments, provide personal protective equipment, and offer regular training. An effective way to protect the workforce is through the use of a job hazard analysis. A job hazard analysis, or JHA, also called a job safety analysis or risk assessment, is a systematic process of breaking down a job into its individual steps to identify potential hazards and determine methods to eliminate or control them before work begins, thereby preventing injuries and illnesses. The goal is to understand what could go wrong, how it could happen, and how to prevent it by implementing controls like safe work practices, personal protective equipment, or other necessary requirements. The benefits of a job hazard analysis to an organization include reducing injuries and illnesses. By proactively identifying and controlling hazards, the risk of workplace incidents is minimized. Improving training. JHAs provide a clear basis for training new employees on safe work procedures. Enhancing communication. They foster open communication about safety concerns between workers and management. Establishing standards. The resulting documentation creates a formal standard for how the job should be performed safely. And facilitating investigations. A JHA can be used as a starting point for investigations when an injury or illness does occur. The type of job hazard analysis being conducted will determine who should be involved in the work, the hazards, the risks, and the benefits to the organization. The types of JHAs include task-specific JHAs. These are focused on identifying hazards related to a particular job or task, such as those involved in using forklifts, production machinery, or other hazardous job assignments. And site-specific JHAs. A more general type of analysis that focuses on the hazards present at a particular worksite at a specific time, rather than a specific task. There are multiple methodologies for conducting a hazard analysis based on the type or information available. The types of hazard analysis methods are qualitative hazard analysis. This method assesses hazards based on their characteristics and the situation in which they occur, but it does not use numerical data. Quantitative hazard analysis. This approach uses numerical data and statistical methods to assess the risk of hazards. And semi-quantitative hazard analysis. This method combines qualitative and quantitative approaches, using numerical data for some aspects while relying on qualitative descriptions for others. When deciding which task or site to complete a hazard analysis, there are some criteria to help prioritize the selecting of tasks. Considerations include high-risk versus low-risk tasks. The task risk should be a key consideration when selecting tasks to analyze. High-risk tasks have a high probability of occurring and a severe potential impact, such as causing death or significant harm, while low-risk tasks have a low probability of occurring and only a minimal or trivial potential impact. Risk is typically assessed by evaluating both the likelihood of a negative event and the severity of its consequences, often visualized using a risk matrix. High-risk tasks require special controls and resources to prevent serious harm, whereas low-risk tasks require only minimal oversight. With limited resources, an organization must prioritize which tasks or sites to analyze first. The prioritization criteria for a job hazard analysis includes history of accidents, incidents, and near misses. An incident is any event that disrupts work or causes damage, while a near miss is a type of incident that had the potential to cause harm or damage but did not, sometimes called a close call or narrow escape. Accidents are a subset of incidents that result in actual harm, injury, illness, or significant property damage. Reporting near misses is crucial for identifying and correcting potential hazards before they lead to serious accidents, fostering a proactive safety culture. Jobs with high injury potential. A job with high injury potential is one in which the inherent nature of the work exposes employees to significantly greater risks of physical harm than the average occupation. These jobs are characterized by hazardous work environments, physically demanding tasks, and dangerous equipment. The risk can be so high that some occupations have fatality rates many times higher than the national average. New or non-routine tasks. A new or non-routine task is any job or activity that is not performed on a regular, frequent basis, is not part of a person's normal daily responsibilities, or has not been done before. These tasks often involve unfamiliar hazards, lack clear, established procedures, or require tasks performed differently than documented, increasing the risk of injury or illness if not managed with proper training and safety measures. And tasks involving multiple workers and/or equipment. A task involving multiple workers and/or equipment is an activity that requires the coordinated effort of more than one person and/or piece of equipment to be completed. These types of tasks, which are also known as multi-resource tasks, require careful planning and scheduling to ensure efficiency, safety, and project success. To conduct a job hazard analysis, you must select a job, break it into individual steps, identify the hazards associated with each step, assess risks, recommend control measures to eliminate or mitigate them, and then review and update the JHA regularly. The first step is to identify and list job steps by breaking down the specific job into its core, individual steps. Considerations include observing the work performed in the actual work environment. Capture the steps and actions taken by the workforce as they perform the work. Avoid being overly broad or overly detailed. Too little detail and hazards may be missed, and too much detail will bog down the process. Stay focused on the task at hand. It is important that at this point to not focus on the hazards, as this phase is about defining the work. Multitasking may lead to missing important components of the job task or work site. And lastly, the process should involve employees who perform the job to ensure buy-in and accurate identification of potential risks. The next step is to identify potential hazards for each step, determining what could go wrong and could cause harm. The categories of hazards include physical. These involve conditions or elements in the environment that can cause harm. Examples include slips, trips, falls, machine, extreme noise levels, radiation, extreme temperatures, poor lighting, and vibration hazards. Chemical. These involve exposure to toxic or hazardous substances, such as liquids, vapor, or gases. Examples include exposures to solvents, adhesives, paints, toxic dust, and other harmful chemicals. Biological. These involve conditions or elements in the environment that can cause harm. Examples include bacteria, viruses, mold, blood or other bodily fluids, insects, and animal waste. Ergonomic. These result from poor workstation design, repetitive motion, or heavy lifting, which place strain on the body. Examples include awkward postures, repetitive motion, improper workstation setup, and long periods of sitting. And psychological. These relate to aspects of the work environment that negatively affect mental and emotional well-being. Examples include workplace bullying, harassment, stress from heavy workloads, job insecurity, and lack of control over work. The next stage is to assess and score the risk through the use of a risk matrix. A risk matrix is a visual grid tool that assesses potential risks by plotting their likelihood against their severity. By intersecting these two factors, a risk rating is determined, which helps organizations prioritize risks, decide which require immediate action, and guide resource allocation for mitigation efforts. Hazard likelihood is the probability or frequency of a specific hazardous event occurring, leading to an unwanted outcome or harm. It measures how likely a hazard is to result in an incident. The likelihood categories include highly unlikely, a very low probability of occurring, below 10% chance. Unlikely, has a relatively low chance of occurring, 11 to 40% chance. Possible, may happen about half the time, 41 to 60% chance. Likely, has a significant chance of occurring, 61 to 90% chance. And highly likely, almost certain to occur, 91% or more chance. Hazard severity measures the potential magnitude of loss, damage, or harm that could result from a hazard, encompassing impacts on safety, property, operations, and the environment. Severity considers the degree of injury, minor to fatal, illness, property damage, or loss of assets such as time, money, and personnel. The severity categories include insignificant or negligible, No or minor injury, no first aid required, or negligible property damage. Minor. Minor injury, requiring first aid, or minor property damage. Moderate. Injuries requiring medical aid, limited days off work, or moderate property damage. Major or significant. Serious injuries, hospitalization, permanent disability, or serious property damage. And critical or catastrophic. Fatality, permanent disability, widespread or irreversible health effects, or catastrophic loss of property. As the likelihood and severity increase, the potential consequence of harm to the worker performing the task increases. To find the risk, find where the likelihood and severity rating columns cross. For example, if the likelihood is rated as likely and the severity is rated as major, then the risk level would be medium-high. The next step is to determine the controls that should be put in place to mitigate the likelihood or severity of the hazard. Controls are methods of identifying and implementing measures to eliminate or reduce the hazards to an acceptable level. The way to do this is by applying the hierarchy of controls. The hierarchy of controls is a system that ranks methods of controlling workplace hazards from most to least effective, prioritizing eliminating the hazard at its source. The levels in the hierarchy include elimination. The most effective control. This involves completely removing the hazard from the workplace, such as stopping the use of a toxic chemical or eliminating a dangerous task. An example is instead of manual handling of a dangerous material, use robotic systems to automate the task and remove the worker from direct exposure. Substitution. Replacing the hazardous material, equipment, or process with a less hazardous alternative. An example is to use a low-volatile organic compound paint instead of a high-volatile organic compound one to reduce exposure to harmful fumes. Engineering controls. These are physical changes to the work environment or equipment that isolate people from hazards. They can include installing a barrier between workers and machinery or implementing a ventilation system. An example is to install a ventilation system in a paint booth to remove paint fumes or use machine guards on equipment to prevent contact with moving parts. Administrative controls. These are changes to the way people work, such as implementing new procedures, providing training, and establishing safety rules. An example is to implement a job rotation schedule to limit a worker's time spent in a hazardous area or provide comprehensive safety training on how to handle chemicals safely. And personal protective equipment or PPE. The last line of defense, PPE includes items like gloves, safety glasses, and respiratory protection, used to reduce exposure when other controls are not feasible or are insufficient. An example is to give workers respirators to protect them from airborne hazards, safety glasses to protect their eyes, and hard hats to prevent head injuries. PPE is the least effective control measure and progressively increases to elimination, which is the most effective. Once the controls are put in place, it is important to rescore the risk. Again, using the risk matrix, reevaluate the likelihood and severity of the hazards to determine the impact of the control and to determine if the risk has been lowered to an acceptable level. If the risk is still too high, then consider additional controls. And if more controls are not an option or do not lower the hazard to an acceptable level, the organization may have to consider removing the task from being performed. Documenting the analysis is an important component of the process. Create a written document that outlines the safe steps for the job, serving as a standard of safe operation. Use a standardized JHA form or template. The JHA format is a structured document used to systematically identify, evaluate, and control hazards associated with a specific job or task. The JHA form can be used to write safety briefings to be communicated to employees before work is performed, integrate the information with standard operating procedures, and incorporate task safety requirements into employee training. Here is a last point. JHAs are not static documents. They must be reviewed and updated as tasks or sites change. JHAs must be updated when accidents and near misses occur, or there are changes to processes, equipment, and the facility. This must be a part of the organization's continuous improvement process and mindset. And like the initial development process, workers must be involved in review of JHAs. Workforce safety must be the top priority of every business. To reduce workplace injuries, employers must understand how to identify the hazards and implement controls, and the use of a systematic approach like a job hazard analysis is an effective way to drive a safe workplace. We hope you found this training valuable. Please click the subscribe button to access additional Food Sure training videos.